about this half value layer thing. Any question, guys, on attenuation coefficient? No, from absorption, attenuation coefficient. Attenuation coefficient is our tissue. Biological attenuation and fluids and tissue other than soft tissue. No?
Okay,
Half
question.
value layer thickness.
The definition of the attenuation here says the sound wave
Weakens.
but at the same time, it's talking about the energy.
The
right?
intensity, yes.
Yeah, okay.
Yes, absolutely. We're talking about intensity. That's why we talked about it. That's why chapter 5 was on intensity before we got into this. Okay? So, the half value layer thickness right here, guys, that is, again, it's my flashcard. My flashcard for you guys. That is the distance sound travels in tissue that reduces the intensity to 1/2 of its original value. Okay? Remember, like I said, the attenuation coefficient, that's also a different way to measure attenuation. Okay? Half value layer thickness is just another way to do that. This is what we're going to talk about impedance. That's another way to do that, right? If you read. Okay. So again, the half value layer thickness is the distance sound travels in tissue to reduce its intensity to 1/2 of its original value. They have that kind of like, if you ever had like a nuclear medicine study, they have those half value layers where the patient is safe to, you know, Pat, help me out. It's safe to walk around, be in the general public because the radiation is already reduced to 1/2 of its initial intensity. Okay? Something similar to that because you just can't walk around right after the injection, going to lunch, eating in the cafeteria, rating everybody with your alpha rays. You know, everybody don't need that radiation you got in the body. Okay? Same thing right here. Half value layer thickness. Okay? Go. So it's just another term to help us measure or describe attenuation. It may also be described as depth of tissue that results in 3 decibels of attenuation and intensity. Of course, right? Because that's half. 3 decibels is going to be attenuation of 3 decibels is going to be 1/2 of the original intensity, right? Dang, see how it's all just connected? It's gonna just build up. Okay. The units of the half value layer are going to be distance or centimeters. Okay. Any unit of distance or length or centimeters. All right. Typical values in clinical imaging are going to be from 0.25 to 1 centimeter. Okay. Some synonyms, and you have to know these synonyms, guys. Anytime I'm teaching you synonyms, you have to know them. All right. Synonyms associated with half value layer are going to be penetration depth of penetration, and the half boundary layer. You guys know me. You never know how I'm going to ask that question. So make sure you know all the synonyms associated with the half value layer thickness.
Do you have an example of the question?
I don't have one on top of my head. But if I'm asking you, if I have a definition, let's say, what is the distance sound travels in a tissue that reduces the intensity to 1/2 its original value, and if I don't have this word up there and I have depth of penetration on there, you know to use that one. I'm trying to get my test questions. I already gave y'all a couple when I gave you the homework, but I will send those numbers. Alrighty. So, half value layer thickness depends on 2 factors: the medium in which sound travels and the frequency of sound. Alright. A thin half value layer is associated with a shorter distance, right? I don't know does it have an image in the book on that? No, it doesn't, so I'll draw one for us. A thin half value layer is associated with a shorter distance traveled. So, thin half value layer is going to be associated with higher frequency sound because we know that higher frequency is going to be absorbed a lot or scattered a lot faster, right? So just think of this is my thin. So that was wet. I missed. This is my thin one. Bang, this is my thick one right here. This is my transducer, guys. Don't laugh at my transducer. Boom, that's my transducer right there. Meaning that when they're talking about the thickness of the value, that means that at this thickness, a thin thickness, that's when that intensity is going to be reduced to half of its original value. Okay, so we know that if the thickness is really thin, that's going to be associated with a high frequency sound because it's not going to be able to travel as deep. Thickness is basically comparing the depth at which sound is traveling. If it's thin, that means it's shallow. Okay, if it's thick, that means it's deeper. Deeper. Superficial right here.
And so that's why it says the medium. So that's the
Absolutely,
medium.
because we already know that the medium it matters, the attenuation rate of different medium. So if it's traveling through lungs, that's going to be associated with a thin half value layer, right? Because it's not going to be able to travel through the lungs very far. Okay? Or if it's traveling through water or biologic fluid, that's going to be associated with a thick half value layer because it's going to be able to travel deeper into the body. So if I have say this is, I think this would be, let's say bone. That's our thin. This is going to be water or biological fluid. It's going to be associated with longer wavelengths. It's going to be associated with high frequency waves. Okay? Because high frequency waves is going to be thin because they're not going to be able to travel deep into the body. Okay? You have to know that when we're talking about thin and thick, we're just talking about the depth within the body. Thin being really shallow in the body. Thick or shallow or superficial in the body. Thick meaning that it's able to travel deeper. So this deeper is going to be associated with probably like an abdomen and the thyroid. I always like using those because those really contrast each other. Okay? Same thing. When we're talking about the medium in which it's traveling through, because we just learned that the different types of medium have different amounts of attenuation. Okay? Again, the more think about it like this, the more fluid the medium has, the easier sound is going to be to travel through it. Remember, that's our medium anyway. That's what the gel is for. The reason we don't use water is because waters are going to dry up and run away, right? That's why we use gel, because it has that fluid consistency, but also it's going to stay on the body. Okay? Because as we already know, sound is going to travel a lot better through water anyway, almost with no attenuation, with no loss of attenuation, no loss of energy. Okay?
So when you run out of gel, can you use a batch of saline?
I'm sorry?
So if you run out of gel, you don't have more gel. If you want to skim, can you use the saline?
That's not going to work either, because the posterior border of that saline is still gonna, if it's this much air, I wish there's a little meme they have, I'm this close to doing something. If it's this much air, scatter, absorption. It's not gonna penetrate the body because it just, that little space between the bag, the saline bag, and the body, the sound is gonna be absorbed in that little space. So you can't use a saline bag. You're gonna have to put some kind of, that's why even when you use a standout pad, that's why they put gel on the other side, right? They put gel on, but that's why you use a standout pad, it's slippery, it's going everywhere, because the gel is on there, okay? If you just use a saline bag that's dry, you're not gonna get any penetration, okay? It's just gonna be scattered. It's not.
When you say superficial and deep, superficial, just like it's hitting the small tissue.
Right, yes, or shallow. Superficial or shallow. Shallow. Yes, superficial meaning like it's close to the skin. Remember that's one of our like
Oh, but you're not talking about the ball. You're not talking about
No. I'm talking about superficial meaning that it's close to the skin. That's all I'm saying with that. A thin half value layer meaning that it's shallow. It's not deep into the body. Because I know that thick and thin can kind of confuse you, right? You talk about thick and thin when we're really talking about depth, honestly. We're really just talking about depth. If it's thin, that's going to be associated with a shallow depth, not that deep into the body, like that 12 transducer when we're trying to do the thyroid. Okay, it looks great. Alright? But when we're talking about a thick half value layer, meaning that it's able to travel deeper or thicker in this case into the body before it loses half of its original intensity. Okay? We're good thinking of it. Did I explain that okay for you guys?
if they have penetration, like penetration of the sound wave.
Penetration, more of like attenuation. How far can this sound travel before it loses half of its original intensity? Okay? Thin meaning that is going to be associated with high frequency, because high frequency is not going to be able to travel that far, right? It's going to be absorbed a lot faster, okay? Also, the type of media. We just talked about the different types of media, meaning that if it's a more solid media, or if it's air, it's going to be attenuated at a higher rate than a fluid-based media, such as biologic fluid or fat. Okay? But good thing is, I understand how value layer thick. I'm trying to make it more relatable, because I know when they're just talking about thin and thick, it doesn't really explain it that well. But I want you to associate thin and thick with depth. Okay? Depth. How far that sound travels into the body. All right? So, reflection and transmission. Let me see something. I got a couple minutes, guys. A couple minutes. I want to get through impedance, and then we're gonna start on incidence next class. All right. So, of course, we know how the sound works. Either it's gonna reflect, scatter, or absorb. Those are three components. Okay. But reflection and transmission, the sound is gonna always come out with an incident sound beam. Some of that, less than 1% of that is going to be reflected back. 99% of that is going to transmit or keep traveling. Okay, all right. The basis for ultrasound imaging are reflection. Without reflection, we wouldn't even have images, right? If we didn't have reflection, we wouldn't even have anything to look at. All right. That's figure 6.9, right there. And notice how that initial intensity, if you're looking at figure 6.9, the initial intensity is a lot higher than the reflected intensity and the transmitted intensity, right? Because it's losing energy, it's being attenuated. Okay, so if we add the reflected and the transmitted beam, that's going to equal our incident beam. Okay, transmission is critical to ultrasound ability to image structures deep in the body. Guys, if we can't transmit deep into the body, we won't see anything. Same thing, if you guys go in the lab and use that 12 transducer today, and you try to do an abdomen, you're not going to see much of anything past 8 centimeters, 9 centimeters.
So you mean transmitting and sending.
Keep traveling through the body. Keep traveling through the body. Okay? Acoustic impedance is an important tissue property that influences the amount of reflection. Impedance just simply means the acoustic resistance to sound traveling in the medium. Okay? If it's more, think about, if you impeding something, that means you're getting in the way of it, right? It's having a hard time to get through that. Okay? If I'm impeding, like, I think, it's a traffic law, you're impeding the progress or something like that. Meaning that you're stopping the flow of whatever's going on. Okay? So, impedance is the acoustic resistance to a sound traveling in the medium. Okay? So, it's a calculated measurement. It's calculated. Everything else we talked about have been not calculated, but what's it saying there? It's been measured. Okay, it's been measured. Same thing when we're talking about like log, and those are just measurements. Those are just kind of relative. This is a calculated measurement. All right. So acoustic impedance is calculated by multiplying the density by the medium at which sound travels in the medium. Okay.
So
Just know that relationship. Density and propagation speed. Density times propagation speed to give you the impedance. Know that formula. That's all I'm gonna say. I'm not gonna give you a number and say this is the density of this structure. This is the propagation speed. You have to know the propagation speed. What is the impedance? I don't care about that. I want you to know how to find out what impedance is. Okay. So if you know that, then you know how to calculate those numbers. I'm not gonna have numbers like that, but you never know what the register is gonna ask you. Okay? But most importantly, know the formula to figure out impedance. Okay? The acoustic resistance to sound. Yes, ma'am.
So the sound traveling can have resistance?
Definitely. We already talked about that when we were talking about attenuation. Wouldn't fluid have less resistance to sound traveling than a bone? Right? Because if it's traveling fluid, it's going to travel a lot easier. It's not going to have much resistance.
No.
If any at all, if it's water. Okay? That's all. We're just expounding on that. We're just
Like
expounding on that.
dolphin, the sound dolphin is
Travels far, travels deep,
Yeah,
travels
in
deep
the
because
water.
it's in fluid. It's in water.
Yeah.
Okay? You can't hear a dolphin outside of that.
So basically the resistance is the how that sound can go faster or slower.
Absolutely. Impedance.
Okay.
It's impeding our sound. Okay? Remember, impedance is calculated, guys, not measured. Measured would be half value layer thickness. That's a measurement. Attenuation coefficient is a measurement. Okay? Alright? So, I think it's my last slide. What? That's weird. Why am I stuff in right there? I gotta see what's up with that. But let me get through the last slide, guys, before I let you guys go. That was so weird. Okay. So the units for impedance would be rails, guys. Rails, often represented by the letter Z. A lot of times they'll say the Z score, the Z number is blah blah blah. Know that the units of impedance are rails, often represented by the letter Z. All right. Typical values range from 1.25 to 1.75 million rails. Okay. Mega rails. All right. Guys, you're always going to have to convert. The students told me they have so many conversions on there. So if you don't know your conversions, come see me. So we still need to iron that out because you're always going to have to know how to convert centimeters to meters, mega to the base unit, rails, okay? Deci, bales, you know, you're always going to have to convert because units are so important when we're talking about diagnostic ultrasound. All right? It's determined by the medium only, of course. That's what we're talking about. It's the impedance it's the resistance of a medium to sound, okay? So it's only determined by the medium, okay? So a structure like I said, fluid would have less impedance than a structure like soft tissue, right? Even though they're similar, but you know, less impedance is going to have less resistance in the fluid than it would in soft tissue. All right. Synonym for impedance would be characteristic impedance, guys. All right. I'm gonna stop right there. Next time we're gonna start JT geometry class talking about incidence.